to liftoff as we look at a live shot from the Odyssey launch platform. As we anticipate today's launch, we have some welcoming remarks from Michel de Rosen, CEO of EUTELSAT.
Tonight's launch is about a new satellite for EUTELSAT and a continuing story of growth for our company. We are embarked on a far-reaching in-orbit expansion program of 8 satellites, which will all be launched by the end of 2015. Together, they will expand our overall resource by almost 30%. EUTELSAT-70B opens a new chapter for business at 70.5 degrees east, in orbital position we opened in November 2002, exactly 10 years ago. With increased capacity and broader coverage, this satellite will enable us to enhance our commercial response to telecom operators, ISPs, government agencies, and video service providers. We will also offer increased flexibility. EUTELSAT-70B is in fact like 4 satellites in one. Indeed, its 48 Ku band transponders are connected to 4 powerful regional beams covering Europe, Africa, Asia, and Australia. The beams can also talk to one another for interconnectivity. So imagine one hop from Melbourne to Frankfurt or from Shanghai to Kinshasa. But now, our eyes are turned towards the Odyssey platform in the Pacific Ocean. I also want to take this opportunity to send my greetings to the teams from EUTELSAT, Astrium, Sea Launch, and Energia Logistics on the Sea Launch Commander, positioned 3 miles from the launch pad. And also to the team in Rambouillet, EUTELSAT, that is impatient to take control of EUTELSAT-70B after its separation from the launcher. Thank you very much.
That was Michel de Rosen, CEO of EUTELSAT. At L-8 minutes 32 seconds, all systems are go for an on-time launch. As we await liftoff, here are some welcoming remarks from Kjell Carlson, President of Sea Launch.
Good afternoon from our launch center in Long Beach, California, and welcome to the launch of the EUTELSAT-70B spacecraft. I would like to extend a special welcome to our EUTELSAT viewers in Paris, representatives from EADS Astrium in Toulouse, France, RSC Energia watching in Moscow, and our invited guests here at Homeport, as well as everyone watching our webcast. This mission represents our 3rd flight of 2012, our 34th flight overall, and our 2nd Zenith mission on behalf of EUTELSAT, a great partner and supporter. We're experiencing excellent weather conditions at the launch site, and I'm pleased to report that the launch countdown is progressing as planned and that all conditions are within our launch commit criteria. At this point in our launch operations, all our systems and teams are ready to go for an on-time liftoff. Today's launch is a 2-burn mission for Sea Launch, with spacecraft separation occurring about 67 minutes after liftoff. So please sit back and enjoy the mission coverage we have organized this evening. Thank you again for joining us.
That was Kjell Carlson, President of Sea Launch. We recorded his remarks earlier for tonight's mission. At just over 7 minutes, we're looking at a Zenith 3SL rocket ready for liftoff from the Odyssey launch platform to carry the EUTELSAT-70B spacecraft to orbit. Built by Astrium, the Eurostar 3000 series spacecraft will provide total satellite power capability of 12 kilowatts throughout the design orbital service life of 15 years. The spacecraft's 48 Ku band payload will provide uninterrupted service and additional capacity and capabilities to EUTELSAT customers from Europe, Africa, Central Asia, and Southeast Asia, reaching as far as Australia. At 7 minutes and counting, all systems are looking good for an on-time liftoff at 20:43:25 UTC GMT. Let's take a look at today's flight profile. From its ocean-based launch site located directly on the equator, At 154 degrees west longitude, a Zenit 3 SL launch vehicle will lift the EUTELSAT-70B spacecraft into an optimized geosynchronous transfer orbit on its way to its final geostationary orbit at 70.5 degrees east longitude over the Indian Ocean. The Zenit 3 SL rocket will begin its ascent phase of flight at approximately 20:43:55 UTC. The first stage of the vehicle will then separate 2 minutes 30 seconds after liftoff, and the protective payload fairing will be jettisoned 79 seconds later at L plus 3 minutes 49. Second stage will conduct a 4-minute 42-second burn, followed by its separation from the Block DMSL upper stage. The Block DMSL will then begin its first burn at 8 minutes 31 seconds into the mission for a little over 5 minutes. The upper stage will then shut down for an almost 36-minute coast period before initiating its second 6-minute and 16-second burn. The spacecraft will next enter another 9-minute, 50-second coast prior to spacecraft separation at L plus 1 hour and 6 minutes over the Indian Ocean. That's our flight plan for today's launch. We are now 4 minutes, 49 seconds to liftoff and counting. The team in the Launch Control Center is making final reviews at this time. The Launch Control Center is located on the Sea Launch Commander, now safely positioned nearly 4 miles from the launch platform. The platform was evacuated before fueling operations began a few hours ago, and all personnel are aboard the ship for the remainder of launch operations. The launch team is progressing through the final countdown procedure, monitoring telemetry from the launch vehicle and the spacecraft to ensure all critical systems are nominal for launch. They're also keeping an eye on both of the vessels, as well as the launch range, to be sure all conditions are within our launch criteria. The Marine crews verify and hold the relative headings of the vessels to maintain exact orientation. Our meteorologists monitor sea conditions in real time using satellite and onboard data, and the launch team monitors the winds aloft by releasing weather balloons at designated intervals prior to liftoff. I want to take this opportunity to extend a very warm welcome to EUTELSAT and their guests and customers gathered at their headquarter offices in Paris, as well as our friends at EADS Astrium in Toulouse, our colleagues and suppliers in Moscow, the Ukraine, and Seattle, and the Sea Launch and Energia Logistics employees gathered here at Homeport and in Bern, Switzerland to view our mission coverage. And welcome to all of our viewers who are joining our live event feed or our simultaneous webcast at www.c-launch.com. We're coming up on a 3-minute countdown status, so we'll listen in to the Launch Control Center.
MD, SO1.
Директор Миссиреса.
По связи. Go ahead. PLU is on internal power and is go for launch.
Бортовое питание БПГ включено, есть готовность к пуску.
Принята готовность к пуску БПГ. MD copies readiness, PLU for launch. MD, MOC.
Директор Миссия, координатор морских операций.
На связи. MD.
As I'm reading, Dr. Valery Aliyev, our mission director for today's flight, confirms all systems are go for launch as the automated countdown continues. The weather for today's mission is good, and at this time, all environmental conditions continue to be within launch criteria. Our current temperature is 81 degrees, with seas running 6.5 feet from the east and winds at 6 knots. All mission milestones are proceeding on schedule. The teams from Sea Launch, EUTELSAT, and Astrium are making their final assessments of launch status before the terminal count begins. At L-1 minute and counting, we are go for launch of the EUTELSAT-70B satellite. Stand by for the terminal count, which you will hear in Russian and English.
1 minute readiness. Stand by for terminal count.
Последние секунды предстартового отсчета.
Ten,
10,
nine,
9,
8,
8, 8,
7,
7,
6,
6,
main engine start
5,
command 4,
4,
3,
3,
2,
2,
1.
1.
Lift off. Main engine is at nominal thrust.
Директор миссии РРС на связи. Прошла команда
Begin
контакт
pitch over.
подъема. Принято контакт подъема. Lift-off command has been
ILV
acquired.
stabilization is nominal. Propulsion system performance is nominal. Flight is nominal. ILV stabilization is nominal. ILV is now transonic.
Директор миссии РРС на связи. Точное время
Main engine
КП
pressure is
20
nominal.
часов 43 минуты 59 и 237 тысячных секунды по Гринвичу. Принято.
Flight is
Contact
nominal.
liftoff occurred at 20 hours 43 minutes 59.237 seconds UTC.
Maximum
Точное время
dynamic
КП
pressure.
20 часов 43 минуты 59 и
stabilization is nominal.
237 тысячных секунды.
Propulsion system performance is nominal. Contact liftoff time was 204359.237 UTC. Flight is nominal. ILV motion is stable. Begin engine throttling. Flight is nominal. ILV stabilization is nominal. Final sequence of throttling. Flight is nominal. Second stage vernier engine ignition. First stage engine shutdown. First stage separation. Second stage main engine ignition command is issued. Main engine nominal throttle up. ILV stabilization is nominal. Pressure in main engine and vernier engine is nominal.
Координатор морских операций, директор миссии. MSC, this is MD. MD
Flight is
MSC
nominal.
на связи. Начать вертолетную инспекцию стартовой платформы. Begin aerial inspection of the LP. Roger. Принято.
ILV motion is stable. ILV stabilization is nominal. ILV flight is nominal. PLF jettison command is sent.
Fairing separation brake wires are confirmed.
Pressure in main engine and vernier engine is nominal.
Brewster ground station confirms receipt of block DM and PLU telemetry.
Moscow Control Center and ACS confirm receipt of TGIS block DM telemetry. ILV flight is nominal. Pressure in main engine and vernier engine is nominal. ILV axial load is nominal.
Директор миссии РВС на связи. Идет приведение ракетного сегмента в исходное состояние.
Main engine and vernier engine performance is
Sequence 4
nominal.
rocket segment is returning systems to the initial state.
Flight is nominal.
4.5 minutes into the flight of the EUTELSAT-70B spacecraft, and the telemetry for the Zenit 3SL launch vehicle looks good. We have confirmation of the first stage separation and jettison of the payload fairing. The second stage engine will burn for roughly 4 minutes, traveling above the atmosphere. Then it will separate from the Block DM-SL upper stage. During this phase of flight, we will hear announcements for the operation of the main engine and the throttling down of this engine. This reduction in thrust allows for a safe shutdown of the main engine.
ILV motion is stable. Main engine and vernier engine performance is nominal. Ground station is receiving launch vehicle telemetry. ILV stabilization is nominal. Pressure in main engine and vernier engine is nominal. ILV flight is nominal.
ACS ground confirms receipt of TGIS PLU telemetry.
Begin second stage throttle down. Main engine and vernier engine performance is nominal. Second stage main engine shutdown confirmed. Vernier engine performance is nominal. Flight is nominal. ILV axial load is nominal. Vernier engine performance is nominal. Flight is nominal. ILV axial load is nominal. Pressure in vernier engine is nominal. Second stage vernier engine shutdown is confirmed. Zenit block DM separation is confirmed. Axial settling thruster ignition is confirmed. Block DM sleeve adapted jettison is confirmed. Low gain antenna is deployed. First block DM main engine start is confirmed. Block DM main engine pressure is nominal. Zenit block DM separation occurred at 205226 UTC. Block DM burn 1 ignition time was 205236 UTC. Block DM stabilization is nominal. Main engine pressure is nominal. Block DM flight is nominal.
We have confirmation that the second stage has jettisoned, and the Block DM main engine will now be in operation for almost 6 minutes. The first burn of the Block DM upper stage boosts the spacecraft into a stable parking orbit. Let's take a moment now to take a look at a short film from our friends at EUTELSAT. The first burn of the Block DM continues. The Block DM is now accelerating with the EUTELSAT-70B satellite at an altitude of almost 130 miles, or 210 kilometers. It is now almost 1,800 miles downrange from the launch platform, heading east over the equator. The main engine on this stage generates nearly 18,000 pounds of thrust, and during this burn will consume more than 17,000 pounds of propellant. Like the first and second stages of the Zenit booster, the Block DM upper stage also uses a clean mix of liquid oxygen and kerosene as propellant. At 12 minutes into the EUTELSAT-70B mission, all systems are nominal. Right now, we're coming up on the end of the first burn of the Block DM upper stage. Let's listen in.
Block DM flight is nominal. Block DM stabilization is nominal.
Директор миссии говорит КМО. По связи. Go ahead. Request permission to step off console. ACS bridge will be backup. Прошу разрешения сойти с оперативной связи. За себя оставляю мостик СКС. Хорошо, спасибо. Copy. Affirmative. Thank you.
Main engine pressure is nominal. Block DM flight is nominal. First block DM main engine shutdown is confirmed. First block DM main engine shutdown time was 205755 UTC. The block DM will coast until 21:28:57 UTC.
We've just learned that the first burn of the Block DM upper stage was completed successfully. The EUTELSAT-70B satellite and the upper stage will now coast in low Earth orbit for a 36-minute period, after which the Block DM will ignite for a second time. During this coast period, mission managers will be observing the onboard systems of the Block DM and the EUTELSAT-70B satellite as they travel over the equator. Team members will be monitoring telemetry in the Launch Control Center and the launch site, and also at support centers in Moscow and Seattle. Sea Launch depends on the Block DM upper stage for all of its missions. RSC Energia builds this component and designed the Block DM SL we use specifically for Sea Launch operations. The Block DM continues to provide excellent performance and has flown over 260 flights in various configurations. At the launch site, our helicopter is making an aerial inspection of the launch platform and will soon transport a red team to the vessel for a closer safety inspection and securing. This red team will be making a determination that the platform is a safe environment for personnel re-entry. About 6 hours from now, people will repopulate the launch platform for post-launch tests. Our live coverage of the launch of the EUTELSAT-70B satellite continues. The Block DM upper stage and the EUTELSAT-70B satellite are coasting in orbit. The Block DM has successfully completed the first of 2 burns, injecting the satellite into a parking orbit. This orbit, and then a second burn of the upper stage, enables the delivery of the spacecraft to a higher orbital perigee height for geosynchronous transfer orbit, which translates into a longer spacecraft lifetime. The spacecraft in the Block DM are now traveling in an easterly direction, taking the equatorial route across the Pacific Ocean, South America, and the Atlantic Ocean toward the African continent. The Sea Launch mission design process is very flexible and allows the spacecraft to take full advantage of the Zenit 3 SL's heavy lift capability. Sea Launch works with each customer during mission integration to optimize the injection conditions that best suit the spacecraft's orbital needs. Our flight designers at Boeing, Yoshinoya, and Energia work together to create a specific optimized mission profile that meets the requirements for each of our customer spacecraft. Once the spacecraft is built and delivered to our payload processing facility at Sea Launch Home Port, launch preparations get underway. Here's what those operations look like. On October 16th, Astrium EADS delivered the EUTELSAT-70B satellite aboard an Antonov 124-100M cargo jet to Long Beach International Airport. The spacecraft was then unloaded and prepared for transit to Sea Launch Home Port. At 2 a.m. the next morning, the spacecraft arrived at Home Port and was brought directly to Sea Launch's payload processing facility, where it was tested, fueled, and encapsulated in the payload fairing. The payload team then transferred the encapsulated spacecraft in what we call the payload unit, or PLU, on November 10th. It was moved from the payload processing facility to the Sea Launch Commander, where it was mated with the upper stages of a Zenit 3 SL launch vehicle. 2 days later, on November 14th, the fully integrated launch vehicle was transferred from the ACS to the Odyssey launch platform. This operation took approximately 4 hours. The following day, the rocket was rolled out of its protective hangar and erected on the launch pad. In its vertical position, the rocket was put through a series of mechanical and electrical tests that verified all systems were in order. At the conclusion of these tests, the rocket was lowered to its horizontal position, returned to the hangar, and prepared for transit to the launch site on the equator. The launch site platform departed Home Port on November 17th, and the Sea Launch Commander followed on November 21st. The two vessels rendezvoused at sea on November 28th, and soon began operations at the launch site at 154 degrees west longitude. The team ballasted the launch platform about 65 feet to its launch depth, and the countdown was initiated at L72 hours. A day before launch, the rocket was rolled out and erected to a vertical position on the launch pad. After final tests and fueling, the Sea Launch system was ready for today's launch, EUTELSAT-70B. Our team in the Launch Control Center at the equator is monitoring all systems, and they report everything is nominal at this time. The launch team continues to monitor the Block DM upper stage and the EUTELSAT-70B satellite as they coast in a parking orbit over the equator. All operations are performing as planned. While the spacecraft travels in space with the Block DM upper stage, let's hear some comments from Dr. Aliyev.
Моя роль директора миссии состоит из 26 задач примерно. Эти задачи можно разделить на 3 направления. Первое направление – это ответственность директора миссии за выполнение всех операций технологического цикла подготовки комплекса «Морской старт» к пуску. Второе направление – это ответственность за выполнение критических операций, критических задач, таких как заправка космического аппарата, заправка разгонного блока, загрузка компонентами топлива стартовой платформы. И третье направление – это руководство и выполнение всех совместных операций с ракетой на комплексе «Морской старт» в базовом порту и в районе пуска. Сюда относятся операции и подготовки и выполнение обзоров готовности, и проведение комплексных репетиций совместных операций, и проведение совместных операций в базовом порту, таких как перегрузка РКН на СКС, с СКС на стартовую платформу, и выполнение заключительного цикла подготовки в базовом порту, сухой вывоз. И сюда же относится самая главная задача – это интеграция руководства пусковыми операциями в районе старта, выполнение графика этих операций и в конечном итоге выполнение пуска. Если говорить совсем коротко, то в ответственность директора миссии входит планирование операций, исполнение этого графика планирования, ответственность за безопасность персонала и оборудования и за успех пуска. Вот эти основные задачи являются предметом моей работы на текущей миссии.
At 22 minutes into today's mission, we're nearly halfway into our coast period, with the Block DM upper stage and the EUTELSAT-70B spacecraft are approaching South America, traveling directly over the equator, as we see in our tracking map. They're taking the satellite to the optimum position for the beginning of the second burn of the Block DM upper stage. While we're in this coast period, here are some of the activities that happened in and around home port before the launch.
Sea Launch is located here in Long Beach, California, and we've been here now since 1997, so this marks the 15th year that we're here. And we've been very, very pleased with the support that we received from the city, the port, the chamber, and all other organizations that we work with here in Long Beach.
The Sea Launch Homeport Complex is located within the boundaries on the eastern edge of the Port of Long Beach.
Sea Launch, when I first got to know them was when I met Shel Carlson, and he was on our board of directors for the chamber, and I've had several tours, and it's just a fascinating opportunity for us.
Homeport's location in Long Beach allows Sea Launch to provide various amenities and cost savings associated with standalone operations and launch campaign costs, both for the satellite operator and the spacecraft manufacturer. It provides easy access for our customers and offers inherent advantages in terms of transportation and operation costs.
To sum up Sea Launch's homeport location into one word, it would be access. We have access to 2 of the world's premier spacecraft manufacturers in Boeing Satellite Systems out in El Segundo, California, and Space Systems Loral on Palo Alto.
Being able to come to a more local area in California has worked out extremely well, and I think our customers are very happy to be here. It's very close to international airports and businesses. When they finish work for the day, it's almost like being at home.
We have heard nothing but positive accolades from all our customers that come here from across the world as they spend time here in Long Beach. And they're always very welcomed by the city and by the port, and they're always very happy to come back.
Long Beach has great weather. Besides the great weather, we're essentially located right between Orange County Airport, LA Airport, right here on the water, on the beach. It's called Long Beach for a reason. We have one of the largest, longest beaches in the world.
Additionally, the City of Long Beach not only offers world-class availability of hotels, dining, tours, and sporting events, but is also very close to a multitude of aerospace machines.